Hi guys, this is section 1.4, college algebra. I hope you found your way to this site. This is where I do my online lectures for my online classes, so I'll just do one for you guys since I'm missing, and I apologize for missing so soon in the semester, but that's the way it goes. So you can see I've got my math lab open. I've got 11 problems to do. These are the ones that I would have normally done in class, so I just do them without questions. That's the only difference. Got my calculator booted up and my paint ready to go. So let's get at it. Okay, first things first, we've got slope. All right, when do we have a slope? Well, we only have a slope if we have a line. It's the only thing that, and I haven't done this in a while, so I might be a little rusty. Oh, come on. Slope. It is rise over run. It is the pitch of the line, right? We have a formula that says y sub 2 minus y sub 1 over x sub 2 minus x sub 1 will give us the slope. And in the y equals mx plus b formula, we have the slope as m. We're going to do our standard line. This is your slope right here, the m part. Okay. A few things about slope. If we have a positive slope, it's going to run uphill. Okay, and uphill means left to right. If we look from left to right on the line, because if you look right to left, it's going downhill. So we always classify it as looking left to right. So that's a positive slope. This is a negative slope because it's going downhill from left to right. This is zero slope. That was supposed to be a straight line, horizontal line. And this is an undefined slope, vertical line. So we have four possibilities there. Okay. Another thing that you need to know about slope is that it never changes. It doesn't change from this point to this point, or from this point to this point. It's constant. Okay, if it's not constant, then it's not a slope. Okay, so that's why other things such as parabolas don't have them, because there's no it's changing all the time. The pitch changes, but here it's always the same. So if we've been given 2 points up in the problem up there, 8, -8, and -10, -8, we can randomly call this point number 1 and point number 2. We could have done it the other way around too. Wouldn't really matter. Then we can label these as x sub 1, y sub 1, x sub 2, y sub 2, right? These are the xy coordinates of point 2 and of point 1. And now we can use this formula here to calculate out slope. So we have the slope, m, is equal to, it says y sub 2 minus y sub 1, so that's this one minus that one. So we have -8 minus a -8. Be careful on your negatives. Then we have -10 minus 8. We're going to do the same thing on our x values. We have -10 minus 8. And we have, I'm going to go through this very slowly here. Subtracting a negative is like adding, right? And here we have a -18, -10 and -8. Here we have 0, right? -8 and +8. -18. 0 divided by anything is 0. Okay? So therefore the slope is 0. So remember, that's this one. Think of an ant crawling up a hill. Up a hill, it's a positive slope. It's hard. Downhill, negative slope. It's easy. Flat line, 0. It's kind of like neutral. And here he falls off the cliff and dies. Poor ant. So we're going to put in a 0 here. Check our answer. And we're good to go. All right. So let's see what else we got. All right. Find the slope between 2 points. Does it matter if they're fractions? Heck no. It doesn't matter if they're fractions or radicals or decimals or whatever. The method never changes. Okay? It's just maybe a little bit harder with fractions. Should we try that one? Oh, you're going to make me do it, aren't you? Yes, you are. I would ask that in class and everyone would go, yeah, you better do that one. That's a fraction. So I go, oh, okay. So we're going to call this point 1 and point 2. We have x sub 1, y sub 1. We have x sub 2, y sub 2 again, just like before. So we want y sub 2 minus, that's this one, minus that one. That's a negative 3. And then we have x sub 2, which is negative a third, minus 5/6. Okay, this one minus that one. And want to do this by hand, or maybe we should just use our calculators? Subtracting a negative is adding. Boy, I like doing fractions by hand, but I know you guys probably wouldn't do it by hand. You know, then you got to find a common denominator and all that good stuff. So maybe I'll just bite the bullet and do what you guys would normally do. I'm going to move that over just a bit. Okay, so I'm going to compute this one first. I've got a negative 1 divided by 3. That's how I have to put in a fraction in this calculator, plus 3. So this should be negative 3 1/3, right? Or no, that's a positive. 2.66. My bad. All right, so again, we can't ever deal with that, so we're going to hit the math key. We hit enter 8/3. Okay, so we have 8/3 on the top there. I think I have Florida on the brain. That's where I'm going anyway. I know, I shouldn't have said that when you're stuck here in the cold. Then we have negative 1/3 minus, you can also put stuff in parentheses. I would suggest that you put your fractions in parentheses just because it contains things better. Then there's no mistaking that you're subtracting a fraction. Math, enter, enter. We've got negative 7/6. And now I'll just use the calculator to divide. 8/3 divided by negative 7/6. It's hard to say. And that is negative 16/7. Okay. We're going to go up in here. We could use this, or we can use, well, let's just use that. We can also use our / key for a fraction. Minus 16. This way we can just fill in the boxes. And it's going to want a simplified fraction. Okay? So this is a great tool to have for fractions if you don't like doing them by hand. I prefer to do mine by hand, but it's okay if you don't. You can use this. All right, let's see here. Let's talk a little bit about this mx plus b thing up in here. We said that m, when it's in this form, it's linear. The highest power on x is 1. We have the number in front of the x is the slope, and the b is the y-intercept. What is a y-intercept? Well, that's where the line crosses the y-axis. It's got to cross somewhere if it's not vertical. Okay? So this point would be 0 something. Let's say it's 2. Looks like about 2. So that's where it's going to cross. Okay? So here we know that the number in front of the x is a negative 8, so we can just put that in there. Right? That's all we need. And it says since the slope of this graph is negative, as x increases, the line decreases. The function or the y values decrease. All right, and it says for every 1 unit increase in x, there is a decrease of, well, what does that mean? Well, usually you want your slope, do you see how slope is meant to be fractional? Well, we can make this into a fraction if we want, so we have negative 8 is equal to negative 8 divided by 1. Okay, so here's your rise and here's your run. These are all the change in the y values. These are the change in the x values. So if that helps, do that. So if we increase 1 unit for x, then we have a decrease of 8 units. And I don't think it wants the negative in there, okay, because it already said it decreases 8 units. All right, so for every 1 unit that we go to the right on the x, we go down 8. That's what this tells us. Down 8 over 1. Down 8 over 1. From here, down 8 over 1, down 8 over 1. It's like a stair step, okay? Why do I ask okay when I can't get any answers? Okay, so let's talk about linear versus nonlinear versus constant, okay? These are pictures of linear. This is the graphical, this is the symbolic, okay? So if it's in this form or you can manipulate it into this form, it's linear. But we also have, you know, m can be 0. We can have a 0 slope, just like here. So we could have something that looks like, you know, y equals 2. Okay, that's a constant function. That means that it's a straight line like this. It's also linear. It also forms a line. So here it says, first of all, determine whether it's linear or nonlinear. And if it is linear, is it a constant function? Well, constant functions have a slope of 0. Okay, so let's keep that in mind. Nonlinear functions have goofy stuff in the function, and I don't know how else to say that, but you're going to have a power other than 1 on your x. You're going to see a radical. You're going to have your x in the denominator. Just anything like absolute value bars or anything goofy going on with the function, and it does not match up to this form, it's not linear. Okay? This one definitely does. We have an mx plus b. It's perfectly in line with the generic formula here. So is this a linear function? Absolutely. Is it constant? No. In order for it to be constant, which would be this one, which would be a horizontal line, we would have to have the slope be 0. We have a slope of a -3, so it can't be constant. That one looks like this, right? It's going downhill. Is it constant? No, it's not. And let me just grab this. Which is the correct graph? Well, I'm not even going to use my calculator because I'm just going to use my logic skills. Is it a V shape if it's linear? Well, no. Linear means it's a line. Is it a parabola if it's linear? No. Linear is a line. All right, now look at the slope. It's negative. That means, does it go uphill like this one or downhill like that one? It's got to go downhill. It's got to be D. Okay? Nice. I love those excellence and fantastics. All right. Linear or not linear? Well, like I said, if it has any power other than 1 on the x, it's not linear. This is a quadratic. This forms a parabola. Okay, that's like that U shape, like this. Okay, so it's not linear. It's not linear, not constant, not linear and constant, but it's just nonlinear. Okay? As a matter of fact, it's nonlinear and it's quadratic. Okay? So here, it's not, this is a cubic, this is linear, this is quadratic. Okay? Always when you have a 2 on here, it always makes a picture like this, or the upside down value. It can go upside down too, it can go this way. So we're in this right here. Fantastic. All right, I promised you some interval notation. We talked a little bit about that set builder garbage yesterday that I don't like to do, so we're going to get into notation. Let me see, hang on for a second. Where is my clear all? I haven't done this in a while. I have to do this with you guys. Select. Okay, so if I select all of this, I think I can delete it. Ha! Nice. All right, so I'm going to go back up. I have to pick my pen again, and we're good to go. All right, so interval, we have notation. Okay, so I'm going to start out with different types of notation. Okay, so first of all, we have inequalities. Okay, we can have single or compound, which are the doubles. Okay, so we can have this, this, or that, right? So this one means that the 2 is included. This one means the 4 is not. Okay, bigger than or equal to, less than, combination of included and not included, that's fine too. Okay, So that's this notation right here. That's inequality. Then we have interval. Pen, hello, there you are. It's like skating. This thing, it's like a rink. This thing is so slippery, it's really hard to write. Then we have interval notation, where this is the included, like this, and you know, obviously you have that, so you could put 2 points in there, or otherwise you have parentheses. So these are brackets, these are the included, and these are not included when you use parentheses. Not parentheses, I said parentheses and then I not included. Brain of a gnat today, not included, okay? We can have combinations of these. We can have one bracket and we can have one parenthesis. That's okay too, or vice versa, all right? So I'm going to stop there for right now, and we've got more types down here. So since this is involving both interval and inequalities, I'm going to just talk about those two. The way that I read this is x is bigger than or equal to -2. Or I can say all values, all numbers, bigger or equal to -2. What really helps to do is to draw a number line to see what we've got going on here. We've got 0 and we've got -2, and I want bigger than -2. So, and it's including -2. So on a number line, which is your third type of notation, you're going to include that and you're going to go that way, right? Aren't you talking about all these numbers forever that way? Okay, what's at the end of forever? The end of forever is a infinity sign. What's at the end of negative forever? Negative infinity. Okay? These two things are not numbers. They're concepts. There is no number infinity. It's just an idea. So whenever you use infinity in any of these, you can never include it because it's not really a number. So these always are paired with parentheses. So to change it over to an interval notation, I want to say I want to go from -2, including -2, all the way up to infinity, but not including infinity. This is the same thing as this, and it's the same thing as this. Do you see how we're always just changing forms? It's kind of like going from 1/2 to 0.5. Same thing, different form, right? So we're taking this inequality notation and switching it over to a interval notation. Okay, so let's see if that one's, well, of course it's on there, it's the first one. Okay, what's wrong with this one? It should be a bracket. This one's saying it's not including. That would be if this line underneath there was not there. And we don't want to go down backwards. We don't want to go to negative infinity. We want to go to positive infinity. So it's A, right? Good job. I know that sounds really weird, but it will get more difficult later. This will come up later, that this has to be smaller. You want the small one on that side, you want the large one on that side. I know that that's obvious now, but it won't always be. So you never want to put the larger number here and the smaller number there. It's always small to large. All right, let's try another one. Okay, here's a double. Okay, we wanted an interval notation, so we're talking about this kind of stuff. If it helps you, draw a line. Okay, we're talking about -3, we're talking about 4. We're going to go down to -3, but we're not going to include it because this does not have a line underneath it, so we're going to have an open circle on this end. The 4 is included, so we're going to have a colored in circle on that end, and we want less than or equal to 4. That's going this way. But we want bigger than -3, so that's going this way. So it's all of this, right? So in interval notation, we're going to not include the -3, right? Oops. And we are going to include the 4. So this is saying not including -3 through 4, including 4. Okay? Let's see what we got here. I think we have to use the keyboard. -3, 4, and my bracket is right underneath my equal sign. Okay? You know where the parentheses are. It's Yeah, it's just underneath the equal sign on my keyboard. All right, so we're just switching forms again. Oh, there's that darn set builder. All right, so far what we have is inequality, interval, and number line form. Now let's get to that set builder. Okay. If you ever do higher levels of math, you'll see this all the time. By about pre-calc, calc, we use that pretty exclusively. X. Okay, so these are squiggle brackets. I don't know what they're called. I just call them squiggle brackets. And this first one says the set of all, meaning all numbers, really, x. So all of x, or all numbers, and then this line, it's like a big long line like that, that's such that, and then here's your condition. So we want to graph all numbers such that 3 is less than or equal to x. Okay, now answer this for me in your head. Are those the same thing? 3 is less than or equal to x. Is that the same thing as x is bigger than or equal to 3? Absolutely. Is it easier to read this way? Absolutely. Okay. This to me looks funny, so I will always turn it around. In an inequality, if you turn these around, you have to flip that. Okay, you can always invert sides. So I want to, in interval notation, I want to express all numbers that are bigger or equal to 3. Here's my silly line. I'm including 3, so I'm going to put a closed circle on there, and I'm going to go toward infinity. Okay? So bracket 3, comma, infinity, parenthesis. Remember, infinities are never included. So we have bracket 3, comma, and here's your infinity key right there. Excelente. All right, these are even easier. I don't even have to do anything with these because they're already here. This one has a bracket and this one has a parenthesis. Boy, that's tough, huh? So you're looking for the -1 with a bracket, and you're looking for the 4 with a parenthesis. It's this one. Don't you wish they were all that easy? Yep. Me too, by the way. Same thing here. We've got a parenthesis, and we go on to this arrowhead means forever. We're going into negative forever. Okay? So this is not quite right because why? Because the bigger numbers on the left and the smaller numbers on the right. Infinity, negative infinity is smaller than 4. So really we want to turn it around and go this way. Okay, so that's where that smaller goes on the left, larger on the right comes into play. Negative infinity is always parenthesed. 4 is parenthesed right here, you can see. And, oh, I love these. These are called curve sketching. And really what it is an interpretation of a graph. We have verbal over here, and we have graphical over here, and we're trying to match them up. We're trying to have this scenario here represented in a graphical form. And sometimes it can be very difficult. I'm going to be giving you an extra credit problem, I think on this first test. I'm going to give it away right now. That involves this, but it's difficult. It's a very difficult concept to do. So I just kind of wanted to show you a little bit about how it works here so that when you get to the extra credit on the test, you kind of have an idea what's going on. Okay, so let's read through the scenario first. A commuter leaves the cinema, drives toward the workplace, gets gas, and continues driving to the workplace. All right, we do that a lot. We went to the movies, we're going to go to work now, ran out of gas, go fill up, and keep going. The G, which is the y-axis, is the amount of gallons of gas that you have in your car, and T is the time. So as we move to the right, T increases, so that means the clock is ticking, right? And as the clock ticks, something happens to our gas, right? If we stay still, as in this picture, the gas in our car is always the same. That means we're parked. We're not going anywhere, correct? If it's going up, what does that mean on your gas? That means that you're filling up, correct? Down means you're moving. You're wasting or using gas, right? So if we look at it that way, we can pick which one closely matches. Now, it's not going to be A, because like we said, that would be just if you're just sitting parked, you're not using any gas. So that one's out, okay? So leaving the cinema means you're using gas, okay? So it can't be this one, because up is filling your tank at the gas station. So A and B are out. So here we're driving, and here we're driving. So it's either C or D, okay? Then we get gas. All right, so this indicates this little upward part right here is the getting gas part, because our G values are increasing. This one doesn't have that. And then we drive more. We're, again, using gas. So here we're at the cinema. We get to the gas station. We fill up, and we go to work. This one is we're at the cinema, and for some miraculous reason, all of a sudden, we're filling up, and we just keep filling up forever. Okay, so it's D. Nice job. And that's it. This is all I would do in the class. Like I said, I hope that it makes sense. I'll be checking my email to help you guys out. But that's it, and I will see you. Now remember, there's no class Monday, so I will see you on Wednesday. And I like to try to have the first 5 minutes of every class be for questions on any homework, anything that's bothering you, anything that you need help with, that kind of thing, and then we start new stuff. So I will see you then. Have a wonderful weekend.